In this lesson, we're continuing to learn about graphing and solving inequalities. For section 3, we're going to be solving multi-step inequalities. And of course, multi-step inequalities are just like multi-step equations, where we have to simplify any parentheses or like terms before we can get to our answer. Take a look at example 1. What do you think is our first step? Well, after we write our line down our inequality symbol and circle our variable, we check to see if it needs to be simplified. Notice how it has parentheses. That's always going to be our first thing to simplify. The 7 out front is touching the parentheses, which means it's multiplying. So we're going to distribute a 7 to both terms inside the parentheses. 7 times 1x is 7x. 7 times negative 3 is negative 21. And we're going to drop everything else down. Next, we're going to check to see if there are any like terms. Notice we don't have multiple x terms, but we do have multiple constants on our left side. Are they on the same side or opposite sides? Same side, combine. Negative 21 plus 9 is going to combine together to make a negative 12. And of course, we're going to drop everything else down. We check, is our left side simplified with like terms in parentheses? Is our right side simplified? Yes. Now we can go ahead and solve. Finish this problem. We get a final answer of x is greater than or equal to 7. Notice how we did not flip the inequality symbol because we divided by a positive. You only have to flip it when what you're multiplying or dividing by is negative. Next, we're going to graph. Our graph is going to have a closed dot because it's equal to, our arrows to the right because it's greater than, and remember, your symbol will match your arrowhead. And there's your final answer for example 1. Go ahead and try example 2. So for example 2, line down the equal sign, we check, do I have any parentheses on my left side? Yes. So we're going to go ahead and distribute what's out in front of the parentheses, which in this case is the 2. 2 times negative 1x is negative 2x. 2 times positive 4 is positive 8. And then we're going to drop everything else down. Next, we're going to ask ourselves, are there any like terms on the left side of the inequality symbol? Yes, we have a negative 2x, which is a like term, with a negative 3x. Notice how the sign goes with the terms. Are they on the same side or opposite sides? Same side, we're going to combine. So we have negative 2x minus 3x, which is going to combine to make a negative 5x. And we're going to drop everything else down. Continuing solving from here, we get our final answer of x is less than negative 7. Notice it's a less than symbol because we had to flip it when we divided by a negative. You only have to flip the inequality symbol when you divide or multiply by a negative. So that's how our greater than turned into a less than. Next, we're going to check our graph. We have an open dot because it's not equal to. It's to the left because it was a less than. Again, noticing how our arrowhead matches our symbol. Take a look at example 3. What do you think is our first step? So if we draw a line down the inequality, we want to check to see if the left side is simplified. Are there any parentheses? Are there any like terms? So if there are like terms on the same side, like we have negative 5x and negative 1x, we're going to combine them on the same side. Same side combine. Negative 5x minus 1x is negative 6x. We're then going to drop down our negative 7, and we're going to take a look at our right side. Are there any parentheses? Are there any like terms? You answered no to both, so we're just going to go ahead and drop down both terms. Our next step is to see if we have like terms on opposite sides of the inequality. We have both a negative 6x on the left and a negative 2x on the right. If you remember from solving multi-step equations, when we have like terms on opposite sides, we need to do the inverse. It's same side combine, opposite sides inverse. I like to move things to the left, so I'm going to go ahead and do the inverse of negative 2x by adding 2x to both sides of the inequality. Simplifying what we have, negative 6x plus 2x is negative 4x. We drop down our negative 7 is greater than, this cancels, and we just have 17 left on our right side. Go ahead and solve the rest of this inequality and check your graph. We get a final answer of x is less than negative 6. Notice you had to flip the inequality sign because we divided by a negative 4. Next, we're going to check our graph. We're going to have an open dot because it's not equal to, and our arrows to the left because we're less than and we're decreasing our answer range. Try your best at example 4. So our first step in example 4 is to check the left side. Are there any parentheses? No. Are there any like terms? Yes. So we're going to have 5x and negative 8x. Same side combine. So 5 minus 8 is negative 3. Their variable is x. And I'm going to drop down the negative 4. And I'm going to check the right side. Are there any parentheses? Are there any like terms? Since we answered no to both, we're just going to drop down both terms. Our next step is to see if we have like terms on both sides of the inequality. We do, with a negative 3x and a positive 3x. So when they're on opposite sides, we do the inverse. Same side combine, opposite sides inverse. So I like to move things to the left, so I'm going to subtract 3x because that's the inverse of this positive 3x. Negative 3x minus 3x is negative 6x. We drop down our negative 4 is less than or equal to our negative 4. Go ahead and solve the rest of the inequality. We end up with the final answer of x is greater than or equal to 0. Notice how we flipped our inequality sign because we were dividing by a negative. Whenever you have 0 in a division problem, I want you to consider this trick up here. If 0 is in the numerator, it is okay to divide. You get 0 as the answer. So again, 0 divided by any number is going to equal 0, and that's okay to do. If 0 is in the denominator, no, you cannot do that, and you get undefined answer. So if 0 is in the numerator, you get 0. If 0 is in the denominator, you get undefined. It's okay to have 0 in the numerator. No, you cannot have 0 in the denominator. And that's just a trick for understanding dividing when 0 is involved. Next, we're going to check our graph. So we're going to have a closed dot because it's equal to, and our arrow is going to the right as we are greater than, increasing. And notice again how our symbol matches our arrowhead. Go ahead and try your best at example 7. So the first thing we want to do is check to see if there's parentheses on the left side. There are, so we're going to distribute. Then we check, are there parentheses on the right side? No, so we're just going to drop it down. We're going to check, are there like terms on the left side? No. Are there like terms on the right side? Yes. So we have 5x and positive 1x. Since they're on the same side, we're going to combine to make 6x. And we're going to drop everything else down. Next, we're going to check if we have like terms on opposite sides of the inequality. We notice that we have a 6x and a 6x. So when they're on opposite sides, we're going to do the inverse. Same side combine, opposite inverse. So the inverse of positive 6x is negative 6x. So I'm going to subtract 6x from both sides. 6x minus 6x gives me 0. I drop down everything else. This cancels. So notice, if I was to simplify this one step further, I would get 18 is less than 17. So now you need to ask yourself, Is that a true statement? Is 18 less than 17? Not true. So that means there is no real solution. Later on in math, you learn about numbers that are imaginary. Sounds pretty cool, right? But that comes later on. So right now, we're really just focused on the fact that there's no real solution to this problem. So if you end up getting your variable terms to cancel, and you get a statement that is not true, you know there is no real solution. Go ahead and try example 8. First thing we want to ask ourselves, are there parentheses on the left side? Yes, so we're going to distribute. Second question, are there like terms on the left side? No. Are there parentheses on the right side? No. Are there like terms on the left side? Yes. We have our constants of 4 and -3. Combining those together, 4 minus 3 is +1, and we're going to drop everything else down. Are there like terms on opposite sides of the inequality? Yes. We have a 9x on the left and a 9x on the right. So I'm going to subtract 9x on both sides of the inequality. Notice this is actually going to cancel on both sides, which leaves me with 6 is greater than or equal to 1. Now, whenever my variables cancel, I'm left with constants. I need to ask, is this true or false? Is 6 greater than or equal to 1? Yes, this is true because, as we know, 6 is a greater number than 1. When you get a statement that is true and all your variables canceled, you are going to have all real solutions. So notice how this problem was very similar to the previous one where our variable terms canceled. We then have to ask ourselves, is the statement true or false? If it's not true, we have no real solution. If it is true, then we have all real solutions. You've completed the lesson notes for this section. Go ahead and complete the practice problems to check your understanding. You are the best student who ever lived.